let's solve one more problem. In this one, find slope at A and C. On A is the support and the C at the quarter span, and deflection at C and E, that is quarter span and half span. So you may get the question in exam asking for find the slope at quarter span and deflection at your quarter span, or they may ask any of this combination. So let's solve a single problem. Now why I have taken only the ACE part? The reason is this is a symmetrical beam, loaded is symmetrical, and this geometry is also symmetrical one. So if you calculate the slope at A, which is always equal to slope at B. Now if you calculate the slope at C, which is equal to D. Now slope at E is 0 because that is the point where you have a maximum deflection. Okay, draw the elastic curve. So I have drawn the elastic curve. Then C is the point where you have a maximum deflection. So if you draw the tangent from C, it will be an horizontal. So it's very clear for me the second referential point. So always for this particular problem, my second referential point is E because theta E is 0. Now first thing we have to calculate is find slope at A. So first find slope at A. So that is what is, I call it as a theta A. Let me call it as a theta A. So this is what is elastic curve. Now you draw the bending moment diagram. So we already discussed this type of problem. Only change here is EI value is changing. So this part of a EI, I call it as a 2EI, and this is what is EI, and this is what is 2EI. Okay, EI is only changing. Now draw the bending moment diagram. So the maximum bending moment diagram is WL square by 8. Okay, then draw the MOREI diagram. So I'll use the bending moment diagram directly as a MOREI diagram. So divided by EI. So if you divide it by EI, so this is what is EI. At the center point, EI is no change. So I'll say I divided by EI here. So this is what is MOREI diagram. But it is not a full part. It's only the half part. Why half part? Let me extend the points C and D over the M by EI diagram. Now in the region A and C, in the region A to C, the value of EI is 2EI. So whatever the things you have done, divided by 2 you need to do. So what will happen here? So it becomes a half. So it becomes a half here. So this is what is the part. Then increases full. So I've drawn it not properly. And then once again decreases. Why? This part it is a half. So this shaded part is my M by EI diagram. So this is my M by EI diagram. The shaded part is my M by EI diagram. Now let's find theta A. Now obviously you can check it out now. I have to go for the method 1, that is the method of integration. Easily I can get the areas or moment. Now theta AE is equal to theta A minus theta E. What is theta E? Theta E is 0 because that's a point of maximum deflection, which is equal to, I'll directly go with the integration concept, integration M by mx by EI into dx. Now give the integration range here. So theta, therefore theta A is equal to integration. What is the integration range? You look at the integration range. Okay, I'll write the integration range here. So it is 0 to L by 2. So 0 to L by 2. Now if you look at here, so this is L by 3 and this is what is L by 2. Since the EI value is changing, I cannot do it directly 0 to L by 2. So for my convenience, let me split up into two parts. So one is 0 to L by 3. So mx by EI becomes 2EI because the value of EI here 2EI. So it is 2EI into dx plus integration. So L by 3 to L by 2, M by mx, there is no change, by EI into dx. Value of EI is EI only. Now what is the bending moment? mx is equal to bending moment at any distance x from A, because A is my origin point. So if you want, I will draw that strip. You take a strip here. This is what is x. Okay, what is the bending moment at any distance? This ordinate part. So this is what we need to get it, mx. This is what is mx. So what is mx? Mx is equal to, we already calculated, and you know that there is no change. Va is equal to wl by 2 into x minus wx square by 2. So mx is, va is wl by 2 into va into x minus wx square by 2. You can simplify it. What are the common here? W by 2 is a common, so w by 2 lx minus x square is mx. Now substitute it in this equation. So theta a is equal to, you substitute it, integration 0 to L by 3, and so w by 2 into 2 is the 4 ei, 2 into 2 is a 4 ei, w into lx minus x square into dx plus integration L by 3 to L by 2. So what will happen here? So w by 2 ei into lx minus x square into dx. So let's do the integration part for this one. You do the integration, so what will happen? Theta a is equal to, so you do the integration, theta a is equal to theta a is equal to integrate, so w by 4 ei, so there is no change in, e is a common, you take it outside, w by 4 e is a common, you take it outside. So let's do the integration. So L x square by 2, range is 0 to I done a small mistake here. I can put it up the range later also. I'll rub it. You can put the later. Okay. Minus L x cube by 3. X cube by 3. So 0 to L by 3 plus, so common here, w by 2 ei into what will happen? L x square by 2 minus x cube by 3. So L by 3 to L by 2. Then substitute the values. If you solve all those things, so I'm not going to solve completely. Now you can solve it. If you solve completely, so what you're going to get is 5 by 162 w cube by ei.